Right. We're live. This lovely Sunday. Second round on the game. I had a little, not a nap, but I took a little rest to think a bit about the Dijkstra problem. And yeah, I think I know. Oh, you saw the notification. Yeah, you're really fast, man. Welcome. Yeah, so I thought about the Dijkstra problem while having a rest earlier, and yeah, think I know how I want to implement it now. It's so basically we'll have a function or a method which gets a list of paths. Oh, really? Interesting that is used there. Good to know. So I read a bit about A star since you mentioned it. Seems like A star is a bit of it's a bit more effective or efficient than Dijkstra's, but I think Dijkstra's then I'm assuming is a bit more simple. So I think that's probably a good start. Yeah, cool. So we start with basically the path of just our starting position, which is one box here. So then that path is very simple. Then like within the function, we're gonna have the goal of creating a list of new paths with let's call this like a 1 as the start, 1, and then we add on something here, create new list of paths, and it's gonna break if it finds the target. It's like v1 versus v2. v3 are arguments of A star. Oh, okay. Or what is v here? Vector? If it finds target, break. Otherwise, call f again with paths n plus 1. And then that will continue the loop. So now it's the second step here. And this is going to be if n plus 1, or maybe we can do that up here. If n is not empty. Because if it's empty, it means that we have reached the end of the possible space to explore. Something like that. Version, okay. Let's get a scratch file. We can just do a like txt. Dijkstra's. What? Wait. Okay. I'm not sure yet if I want this to be a class or like how I want to represent this in Java. But we have kind of want to write this in Python code and then translate it into Java. Def. No. Right, and this paths thing has to be a list. Because we don't know how long it's going to be. Paths, and then path 0 is going to be new path with our current position. This square. This dot square. So path, we can import this. Why is this cannot resolve? Yeah. Path of game. New path. It has a square. Okay, good. Maybe I should make the text here a bit bigger in case someone is watching it on the phone. Something like that. Yeah. It's much better. Let's see if I can handle it though. It's very big for me now. Meaning I can see less code. So why is this complaining? Right, I need to create a list. Let's pause this one. List. Java linked list. Because we're not gonna know on the path how long it's gonna be. So we need to be able to add a new one whenever we want to. Linked list. Let's just check Java list. There's so many types: array list, attribute list, copy on write, array list, linked list. Okay, it's an interface, and this is a class. Oh, here's this term that you introduced me to yesterday, deck interface. So what's a deck here? Linear collection that supports elements insertion and removal at both ends. Double-ended queue. Oh, that's what it stands for. It's usually pronounced deck. Deck implementations place no fixed limits on the number of elements they may contain. I don't need a deck. I just need to add on. Yeah, linked list with list, yeah. That index into the list will traverse the list from the beginning or the end, whichever is closer to the specified index. Okay, makes sense. I think usually I'm gonna want to traverse it anyway. It's not synchronized. If multiple threads access a linked list concurrently, and at least one of the threads modifies the list structurally, it must be synchronized externally. A structural modification in any operation that adds or deletes one or more elements. Merely setting the value of an element is not a structural modification. Okay. Synchronized list. How do I construct it? Can I get an example? The specified collection. Okay, here. Oh, linked list and then the type. Oh, all right. New linked list string. Okay, let's try that. Paths equals new linked list path. And now we can do, hopefully, paths dot add it's not public. Interesting. I think path. Wait, the path is the linked list, but also the list of paths has to be a linked list. So I don't know how long that's gonna be either. So same here then. Linked list. Square. Squares equals new linked list square. Oh, right. Squares. Ah, I don't have to be explicit. I can just do that. Okay, same here then. Should I call it path or squares here? Making the matrix has been the most fun so far. Nice. What are your achievements in the last few hours? Let's say last 20 hours or so. Path or path or squares. Path.path doesn't sound very good. Now we can just do add square here. I mean, one good thing about Java is that I'm not able to run the code now, which is unfortunate. I usually like to add stuff in really small increments and see what works, but at least I'm getting checks in like the IDE to see that this is going to compile, which helps quite a bit. Mostly birthday stuff for my girlfriend, but got up like 1.5 hours ago. Just been working on Matrix. Nice, nice dude. Are you in a suit today? I mean, Squares is a bad name because it's not just a universe of squares. They have a order. Maybe this should not be called path. Maybe this should be called like branch. Branch dot path instead of path dot squares. But I mean, nodes would sound good. That means squares is also okay for now. It's so cold. I made vec float, vec double, vec generic, stack q, a lot of stuff, array stuff. So you made, okay, so you're making your own. They're not in the standard library or what? It's like 26 and I'm in the attic with no insulation or heater. Yeah, that's, I feel you. I mean, it's not that cold right here right now, but like a week ago or so, they were fixing the heating in our building, and it was out for like 3 days while it was negative Celsius, so around 20 something Fahrenheit. Oh, you made them like MVP, okay. Yeah, node and node list. I just want to be coherent because I'm calling it squares. Like I have a board and the board have squares, so maybe the path can have squares. I think that's fine actually. It was 21 last hour. Public. Each is pretty basic. They're not like 300 to 700 lines of code. Isn't the best metric, but they have a good bit though. And tests mostly, but more like fixtures, not full coverage. Cool, man. Find path to closest enemy. Enemy found, false. I think I don't need to do this. Actually. We don't need to do a while loop. At all. We should do this with recursion. So we start with adding a path with this current square. So this is they are 300 to 700 lines of code each. That's a lot. But yeah, as you say, that's not necessarily a good measure. Unfortunately. Vända? So Vända? Vända? Vill du ha hjälp? Okay. Create a new list of paths. That's what we do here. Function paths. So we need to call this method something. Scan paths for enemy paths. Can we do just return? Create method. Path, yes. Yes. And we want this to go through all squares. around the end node, end square of every path. Go through all square. No, what am I doing? This should create a list for us. Go through squares around the end square. The path. Super good method name. For find all squares around the end square of the path. So for square, square, searched square. And for each one, we need to make sure that it's not part of any other path in our list. Oj. Behöver du hjälp? Ring mig i så fall. What do you mean professional? You mean with the long method names? Can you just have a bool that literally is in use bool? Yeah. I was thinking about that. I hear you're doing C, because now I'm thinking I want to be able to do, like, it's very low level how you're thinking, but I want to be able to do pathfinding from multiple places at the same time. So I don't want to end up risking that these pathfindings are like interfering with each other. Check the pointer. See if it's empty. Yeah. The pointer of what? There is a null pointer, right? I'm not following now. Yeah, but I mean the squares. Yeah, maybe, because like all of the squares, you can see them here outputted like as text. They have, as it's built now, they have two fields, so to say. One is what it's occupied by, and one is the terrain. And then we have a game object here, so like a goblin, and then we have a warrior. And I want both of these to be able to path find at the same time. So like if they are enemies, I want them to be able to find each other. And so the warrior might be pathfinding, looking through the squares, and the goblin might be doing it as well at the same time. if it has data in use in some capacity not equals null point, like constant 0x000. So what would have that null pointer, do you mean? If searched square not in paths. I'm gonna write this in sudo for now and then build all the functionality. The node or maybe like the head or tail aren't null, like one of them is attached to a list that's linked. I think I don't know all the info for the issue you're solving. Yeah, maybe. Or maybe you are seeing something I'm not seeing. But let's try it this way. And then I'm gonna try to refactor it and make it smarter. You don't know Java well. Yeah, that makes two of us. I am more so speaking conceptually. Yeah, I know. It's more interesting to think about it conceptually. I think that's usually more, or I guess it's a different type of challenge, figuring it out conceptually and then like how to actually implement that concept. For blah blah blah. So if so we're looking through all the squares around it. If that square we're looking at is not in any other paths, we want to create a new path I think we need to figure out the naming of this later or at some point. Next node paths. New linked list. And this is where we put the next iteration of lists. The conceptual part is the hard part. Once you know it and best practices, it's boom, bang. Yeah. Right. It's true. It's the boom, bang we're after. Next node paths dot add new path. Wait, scan paths. So we first need to go through, so we need to do multiple iterating things here. So for paths, And this goes in there. Yeah. The end square of the path. This needs a path, which is this one. And then it's looking for everything around it at the end. Square not in other paths. Next node paths, add new path, and this is where we add path searched square. Yeah, I do keep a list of the paths. And I'm thinking of iterating in that through that here, square not in other paths. And this is gonna like access that list somehow. And I'm just gonna look through it to see. Yeah. Hmm. Here there should be some win condition. There's another if here. It's like co-op, yeah. It is. If is enemy is an enemy, search square. I mean, there's so many levels now of methods I need to create to make this work, but hopefully it will be worth it in the end. Cool, because I don't know Java the problem, so I'm thinking about that while I'm solving my own similar issues. Yeah, nice. Is an enemy. No, contains an enemy. Searched square. This is where we do return. New path. Path searched square. Then we found it, and we have the path, the fastest path to it. You got sleep, so your brain exists. Feel like I lose 15 to 20 IQ points after 4 hours awake. Yeah, I know the feeling. For sure. And then you're like, especially when you're in that state and you know how good it can feel, then it's like, oh my god, what's going on? Like, how do I get back to this mode that I was in earlier? But yeah, sleep usually helps. Sleep, meditation, working out, walking.